In this video, we're going to dive into C++ operators. Operators are essential building blocks for creating expressions and performing operations in C++. They allow you to manipulate data, perform calculations, make comparisons, and control the flow of your programs. We will discuss different types of operators like arithmetic operators, assignment operators, comparison operators, logical operators, and bitwise operators. Let's start with arithmetic operators in C++. These operators allow you to perform basic mathematical calculations in your C++ programs. Here's a list of the common arithmetic operators. The plus sign is for addition, the minus sign is for subtraction, the asterisk is for multiplication, the forward slash is for division, the percentage sign is for modulus, which gives the remainder of a division. Then you have plus plus for incrementing a variable, and minus minus for decrementing a variable. Now let's look at some code. Here we have two integer variables, a which is assigned the value 10 and b which is assigned the value 3. We can use the addition operator to add a and b, and store the result in the sum variable. Similarly, we can subtract b from a to find the difference, multiply a and b to find the product, divide a by b to find the quotient, and use the modulus operator to find the remainder of the division. We also have the increment and decrement operators. The a plus plus increments the value of a by 1, making it 11, and b minus minus decrements the value of b by 1, making it 2. Now let's explore the increment and decrement operators in more detail, focusing on the difference between prefix and postfix behavior. Prefix increment or decrement operators change the value of the variable and then return the updated value. When you use plus plus x, the value of x is first increment, and then the new value of x is returned. Similarly, with x, x is first decrement, and then the new value is returned. Take a look at this code. We initialize x to 5. Then we assign plus plus x to y. This means that x is first increment to 6, and then this new value 6 is assigned to y. Similarly, if a is 10 and we assign a to b, then a is first decrement to 9, and then this value of 9 is assigned to b. On the other hand, postfix increment or decrement operators return the current value of the variable, and then increment or decrement it. When you use x plus plus, the current value of x is returned, and then x is increment. And when you use a, the current value of a is returned, and then a is decrement. For example, if x is 5 and we assign x plus plus to y, y is assigned the current value of x, which is 5, and then x is increment to 6. Similarly, if a is 10 and we assign it to b, then b is assigned the current value of a, which is 10, and then a is decrement to 9. Let's move on to assignment operators in C++. These operators are used to assign values to variables. The most basic assignment operator is the equals sign, which simply assigns the value on the right to the variable on the left. In addition to the basic assignment operator, C++ provides compound assignment operators that combine an operation with assignment. For example, plus equals adds the right operand to the left operand and assigns the result to the left operand. Similarly, minus equals subtracts the right operand from the left operand and assigns the result to the left operand. Asterisk equals multiplies the left operand by the right operand and assigns the result to the left operand. Forward slash equals divides the left operand by the right operand and assigns the result to the left operand. Percentage sign equals finds the modulus of the left operand divided by the right operand and assigns the result to the left operand. And finally, you have bitwise operations in assign, which perform bitwise operations on the operands and assign the result to the left operand. Here's an example. We start with x equals 10, which is a simple assignment. Then, x plus equals 5 is equivalent to x equals x plus 5, so x becomes 15. X minus equals 3 is equivalent to x equals x minus 3, so x becomes 12. X asterisk equals 2 is equivalent to x equals x times 2, so x becomes 24. X forward slash equals 4 is equivalent to x equals x divided by 4, so x becomes 6. And x percentage sign equals 4 is equivalent to x equals x modulus 4, so x becomes 2. C++ also allows chained assignments, where you can assign the same value to multiple variables in a single statement. For example, A equals B equals C equals 5 assigns the value 5 to all three variables. Now let's delve into comparison operators in C++. These operators are used to compare values and determine relationships between them. They return a Boolean value which is either true or false, based on the comparison. Here are the main comparison operators. Double equals checks if two values are equal. Exclamation mark equals checks if two values are not equal. The greater than sign checks if the left value is greater than the right value. The less than sign checks if the left value is less than the right value. Greater than or equals to checks if the left value is greater than or equal to the right value. Less than or equals to checks if the left value is less than or equal to the right value. The three-way comparison operator, introduced in C++20, compares two values and returns an object that indicates whether the left value is less than, equal to, or greater than the right value. Let's see these operators in action. We have int a equals 10 and int b equals 20. Then bool is equal is assigned the result of a double equals b, which is false because it is not equal to b. Bool is not equal is assigned the result of a exclamation mark equals b, which is true because it is not equal to b. Bool is greater is assigned the result of a greater than b, which is false because it is not greater than b. Bool is less is assigned the result of a less than b, which is true because it is less than b. Bool is greater eq is assigned the result of a greater than or equals to b, which is false because it is not greater than or equals to b. And bool is less eq is assigned the result of a less than or equals to b, which is true because it is less than or equals to b. Comparison operators are commonly used in conditional statements. For example, if a is less than b, some code will be executed. Now let's explore logical operators in C++. These operators are used to combine Boolean expressions and perform logical operations. Here are the common logical operators. Double ampersand represents logical AND. This operator returns true if both operands are true. Double pipe represents logical OR. This operator returns true if either operand is true. Exclamation mark represents logical NOT. This operator returns true if the operand is false, and false if the operand is true. C++ uses short-circuit evaluation for logical operators. For and if the first operand is false, the second operand is not evaluated because the result will be false regardless. For or if the first operand is true, the second operand is not evaluated because the result will be true regardless. Let's look at an example. We have bool a equals true and bool b equals false. Bool result 1 is assigned the result of a and b, which is false because both operands are not true. Bool result 2 is assigned the result of a or b, which is true because at least one operand is true. Bool result 3 is assigned the result of not a, which is false because it is true. You can also combine logical expressions. For example, if x is 5, y is 10, and z is 15, then bool result 4 is assigned the result of x less than y, and y less than z, which is true because both conditions are true. And bool result 5 is assigned the result of x greater than y, or y greater than z, which is false because both conditions are false. Let's now discuss bitwise operators in C++. These operators allow you to manipulate individual bits within integer values. They are useful for low-level programming and tasks that require fine-grained control over data. Here are the common bitwise operators. The ampersand represents bitwise and. This operator performs a bitwise an operation on the operands. The pipe represents bitwise OR. This operator performs a bitwise or operation on the operands. The caret represents bitwise XOR, also known as exclusive OR. This operator performs a bitwise XOR operation on the operands. The tilde represents bitwise NOT, also known as complement. This operator inverts the bits of the operand. Double less than sign represents left shift. This operator shifts the bits of the left operand to the left by the number of positions specified by the right operand. Double greater than sign represents right shift. This operator shifts the bits of the left operand to the right by the number of positions specified by the right operand. Let's see some examples. We have unsigned into equals 5, which in binary is 000000101, and unsigned int b equals 3, which in binary is 000000011. Unsigned int c is assigned the result of a and b. The bitwise and of 000000101 and 000000011 is 000000001, which is equal to 1. Unsigned int d is assigned the result of a or b. The bitwise or of 000000101 and 000000011 is 000000111, which is equal to 7. Unsigned int e is assigned the result of a XOR b. The bitwise XOR of 000000101 and 000000011 is 000000110, which is equal to 6. Unsigned int f is assigned the result of not a. The bitwise not of 000000101 is 1111 1010. Let's take a closer look at the shift operators in C++. The left shift operator shifts the bits of the first operand to the left by the number of positions specified by the second operand. This is equivalent to multiplying the first operand by 2 raised to the power of the second operand. Here's an example. Unsigned int x equals 5, which in binary is 000000101. Unsigned int y is assigned the result of x left shift 1. This shifts the bits of x1 position to the left, resulting in 1010, which is equal to 10. Unsigned int z is assigned the result of x left shift 2. This shifts the bits of x2 positions to the left, resulting in 100, which is equal to 20. Mathematically, x left shift n is equal to x times 2 to the power of n. For example, 5 left shift 1 is equal to 5 times 2 to the power of 1, which is equal to 10, and 5 left shift 2 is equal to 5 times 2 to the power of 2, which is equal to 20. The right shift operator shifts the bits of the first operand to the right by the number of positions specified by the second operand. This is equivalent to dividing the first operand by 2 raised to the power of the second operand. Here's an example. Unsigned int x equals 20, which in binary is 00010 Unsigned int y is assigned the result of x right shift 1. This shifts the bits of x1 position to the right, resulting in 1010, which is equal to 10. Unsigned int z is assigned the result of x right shift 2. This shifts the bits of x2 positions to the right, resulting in 100101, which is equal to 5. Mathematically, x right shift n is equal to x divided by 2 to the power of n. For example, 20 right shift 1 is equal to 20 divided by 2 to the power of 1, which is equal to 10, and 20 right shift 2 is equal to 20 divided by 2 to the power of 2, which is equal to 5. Now let's talk about operator precedence in C++. Operator precedence determines the order in which operators are evaluated in an expression. Operators with higher precedence are evaluated before operators with lower precedence. Here's a table that shows the precedence of common C++ operators, from highest to lowest. The highest precedence operators include scope resolution, function calls, array access, member access, increment, and decrement. The next level of precedence includes unary plus, unary minus, logical not, bitwise not, dereference, and address of. Then comes multiplication, division, and modulus, followed by binary addition and subtraction, bitwise shift operators, comparison operators, equality operators, bitwise and bitwise XOR, bitwise or logical and logical or. Finally, the lowest precedence operators are assignment operators. Let's look at some examples. In the expression int result 1 equals 10 plus 5 times 2, the result is 20, not 30, because multiplication has higher precedence than addition. In the expression int result 2 equals 10 plus 5 times 2, the result is 30, because parentheses override the default precedence. In the expression int x equals 5, y equals 10, z equals 2, and int result 3 equals x plus y times z divided by 2 minus 1, the result is 9. This is because the expression is evaluated as x plus y times z divided by 2 minus 1. Here's a best practice tip. Use parentheses to make your code more readable, and to ensure operations are performed in the intended order, even when the default precedence would give the same result. Let's summarize the C++ operators we've covered in this video. We discussed arithmetic operators, which perform basic mathematical operations such as addition, subtraction, multiplication, division, modulus, increment, and decrement. We also covered assignment operators, which store values in variables using operators like equals, plus equals, minus equals, asterisk equals, forward slash equals, and percentage sign equals. We explored comparison operators, which compare values and return a Boolean result using operators like double equals, exclamation mark equals, greater than, less than, greater than or equals to, and less than or equals to. Then we talked about logical operators, which combine Boolean expressions using operators like double ampersand, double pipe, and exclamation mark. We looked at bitwise operators, which manipulate individual bits using operators like ampersand, pipe, caret, tilde, double less than sign, and double greater than sign. And finally, we briefly mentioned other operators like the ternary operator, size of dereference, address of member access, and pointer to member access. Here are some best practices to keep in mind when working with operators. Always use parentheses to clarify operator precedence. Be careful with increment and decrement operator placement, as prefix and postfix behavior can lead to different results. And avoid complex expressions with multiple operators, as they can be difficult to read and understand. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.